We're going to begin by looking at variable declarations, the way that you define variables in Kotlin. Now, the Kotlin types are similar to Java types in terms of names, so you have things like int and float and whatever. However, they start with a capital letter, but don't worry, they are primitive types by default. If you make them nullable, then yeah, they become reference types, but by default, they're primitive types. So let's declare a variable. So I'll say val a int equals 64. We shouldn't really be calling it a variable. I'll explain why in just a moment. But for now, we're defining a value of a, which is equal to 64. This is how the declaration looks like. So essentially, you have the type after the name of the variable. So you have value of a, colon, then the type, and then the actual initial value. And similarly, we can define a long value, so b of type long equals 123, for example. Now, you cannot have multiple declarations on a single line, so you cannot do something like c equals 3 and d equals 4, for example. This doesn't work, unfortunately, so you have to do it sort of one by line. Now, floating point values, if we do something like val c of type float equals 2.3, for example, this isn't going to work. You'll see that there is an inspection here because the floating point literal does not conform to the expected type. You see, if you don't put a postfix, then Kotlin treats this as a double, and it doesn't let you assign a double to a float. So the way to fix this is to add an f. You can add a small f, you can also add a capital F, and that makes it all right. So that makes this literal a floating point literal, and we save it, we bind it to the value c. All right, and similarly for double, we would say val d double equals, and here you can say something like 12.3, for example. You don't have to put a postfix, and you can also use the exponential notation. So I can say this is 12.3 to the power times 10 to the power of 5, and the way you do it is you write 12.3 E5. Now, let's print out these values. So I'm going to use the built-in Kotlin function println, which is just another way of doing system out println. And here we can feed it virtually anything. I'm going to feed it a string which is going to reference all of these values. And so I'll print A, B, C, and D. The exact details of the syntax with the $sign will be explained later on, but I'm sure you've already guessed what's going on. Essentially, we have a string being interpolated. So into the string, we put the values of A, B, C, and D. So let's actually run this and see what we get as the end result. All right, so we get 64, 123, 2.3, and notice the last number, that's essentially 12.3 multiplied by 10 to the power of 5, so that's 1,230,000. All right, so these are fairly simple things. However, remember I said we shouldn't really be calling them variables, and the reason for that is that you cannot actually change their value, so they don't actually vary, in the sense that when you declare something as val, it means you cannot change it, it's immutable. So if I write a equals 5, I don't even have to compile it. You can see that the IDE is telling me that val cannot be reassigned, so there you have it. You cannot do it this way. Okay. So, but one interesting observation is that you can declare the variable first of all. Like, let's say I declare value e to be of type int, and then somewhere down the line I give it a value. Somewhere down the line I say e is equal to a, and this is completely valid. So effectively, even though I'm making something which is supposedly immutable, I can give it a value at a later stage. The key aspect here is that after I give it a value, I cannot give it a second value. I cannot say e equals 4. You can see that this is immediately highlighted by IntelliJ IDE, and it's telling me that basically I cannot do this. So this is something worth bearing in mind. When working with values, when working with val declarations. So if you want something which doesn't change by itself, then you use val. By the way, when I say doesn't change, I mean that you cannot reassign the value. That's not to say that you cannot change its internal. So for example, if I make something like, say, a string buffer, and I make it with the word test, then I can change the string buffer itself. I can say f.replace, sort of replace the first character with a capital T, for example. That's completely normal. However, what I cannot do is I cannot say something like f equals and make another string buffer with some new value. This wouldn't work. So I cannot, if I declare something as val, I cannot change the actual what it's bound to, so to speak, but I can change its internals provided it has the methods for doing exactly that. So let's just print line the val, print line the string buffer to kind of demonstrate what's going on here. All right. Okay, there we go. So I capitalized the first letter effectively. Okay, so this might seem a bit inconvenient. Like, why is everything so immutable? What can we do about it? Well, Kotlin actually has two types of declarations. One is val, where you keep something as immutable. The other is var, and this is more like what we would call a variable. So a variable g taking the value, well, being of type int can be assigned 123, but later you can reassign it to the value of 45. So if it's a var, then you can change it. If it's a val, then no, you cannot change it. You'll see lots of inspections all over the place by IDEA saying that the assigned value is not used, blah, blah, blah. I'm going to start suppressing them almost religiously here in the, well, actually, maybe I can suppress them globally in the entire file. No, just in a particular function. Okay, well, that's fine. I guess it will have to do for now. So I'll be having lots of these all over the place, I guess, just so that they don't distract us. Okay, so I have a variable. I can change its value, and obviously I can print it out, whatever. So there's absolutely no problem whatsoever in this regard.